Can you guys hear me? I think we can. So it's all good. We'll wait for a couple of more minutes till everybody joins. You can just put some comment in the live chat section if you are here already. Okay, we'll wait for 5 more minutes before we start. Yeah, we would start maybe 5 minutes past 7. Please leave any comment on the chat section. I'll respond to that. Yeah, we'll start exactly at 7 o'clock, 7 p.m. Just for any comment, just leave it in the chat section. I'll respond to that. We'll start precisely at 7. Just in case. We'll start precisely at 7. Maybe wait a little bit more for some people to join, maybe 2 or 3 minutes. Then we'll just start off precisely at 7. You can leave any comment in the chat section. And yeah, if I could, I have a laptop on my side just to read the comments. Um, any questions at all before the session or anything? You can just put your comments there. I can respond. Yeah, if you already joined us, you could just say a hi in the chat section so I can know whether anyone has joined. If you can hear me, I just want to make sure that. We'll start at around 7:03 or something, wait some time for people to join, and then we'll start off. Can we get started? I think we can get started slowly. So why don't we do that rather than some people, a few people have already joined us, so we don't want to. Yeah, a few people have already joined, so I'd rather not waste time waiting for others. But so yeah, I think we can start off. So I hope you can see the screen pretty well. I'll maximize it for now, and so we'll just talk about what we will be covering in this section. And let me start with what the agenda of the section will be. So first we'll cover a little bit about the basics of the TensorFlow, what TensorFlow is, how you can, at the very basic level, how you can code it. Um, we'll also go into a little bit of the basics of of deep learning. And later on, we'll get into a little bit more specifics on TensorFlow serving. So what is TensorFlow serving? TensorFlow serving is what you do right after you've trained your model. So deep learning has different components. You can extract the data, you can train the data, you can train the models with your data, and finally you need to make it available for people across the world to use your models. And that's where serving comes in, and that's what we are primarily focused on as a startup. We serve deep learning models in a production-like scenario with low latency, high availability, so on and so forth. Uh, so that would be the agenda of the meeting for the session. First, we'll cover a little bit about deep learning, then about TensorFlow, then about TensorFlow serving, and finally, if we have time or something, I'll go into how you can install TensorFlow serving on an AWS machine, and how you can upload your models to our service. That's the final thing that we will be covering. If you have any questions anytime, just put it on the live chat session. I have a laptop on my side where I'm monitoring that. So if you have any questions at all anytime, just leave it there. I'll try to look at it. I'll intermediately look at it, and I'll try to address them as quickly as possible. So let's get started then. So a little bit about myself, about the person taking this presentation. My name is Rahul. Hi. I used to be a developer at Microsoft for 4 years or so, 4.5 years. I worked in the Bing search engine, a team called Document Understanding. So what we do is try to figure out what a document is. If it's like a Wikipedia page about Bill Gates, we tell you it's information about Bill Gates. If it's a news article, we tell you it's a news article, whether it's spam, junk, adult. We try to classify the documents into different buckets. That's what I used to do, or a bunch of those buckets. Right now, I am a CEO and founder of a company called Simple Intelligence. So we focus on serving deep learning models in production. So you might ask me what serving is. Serving is what you do after you train a deep learning model. So right after training, you need to make it available for people across the world to use it. And that's where we come in. We give you efficient ways by which you can serve models in a production-like scenario. It's actually built on top of an open source framework called TensorFlow Serving. I'll go into the detail of that soon. So let's get started. At the start of it, I will go through the very basics of deep learning. Then I will go into a little bit more on the TensorFlow, and finally into TensorFlow Serving. Finally, I'll show, maybe if we have time, a little bit on how you can install TensorFlow Serving on an AWS machine. That would be the agenda of the meeting. Okay, let's get started. So it primarily starts with, like, the entire thing is a dog cat classifier. That's how, like, most of the training starts this way. How can you recognize whether a picture belongs to a dog or that of a cat? There are a bunch of ways to do this. In traditional programming language, you need to write an f of x to do this, a function. The function can be coded manually. There are a bunch of ways to do this. So let me get a pen. You can look at the distance between the eye. Since a dog has a protruding nose and a mouth, you can look at that distance, maybe something like a pointed ear, the shape of the tail, so on and so forth. But if you're doing it for multiple entities and for multiple images, it becomes a laborious task, right? You want a model to recognize apples and oranges or different brands of cars. You will have to hand code these functions over and over again. So it becomes like really difficult. But what if this f of x can be formed during runtime? You have a list of inputs, labeled inputs. Let's say that I have a list of images of cats and a list of images of dogs. And I can give it to a deep learning framework such that the deep learning framework would learn and form the f of x on its own during runtime. So you would be saving a lot of effort in terms of hand coding these features, like the shape of the ear, the width of the nose, so on and so forth. You don't have to worry about all that. It just happens at runtime. So that's kind of at the basic level of what deep learning is. From traditional programming language. In traditional programming language, you put a lot of effort into manually coding these functions, but in deep learning, just by based on inputs and output, the f of x gets formed automatically. So how do I do this? What are the different ways which I can do this? There are a bunch of programming languages out there. Each company releases their own version of these programming languages. Microsoft released CNTK. Disbelief, I believe, was from Google. Facebook uses Cafe. The primary difference between the left and the right is that one uses a config file. So you can use like a JSON or an INI file. You can repeat the different layers. So a deep layer would look like something like there would be a first layer, which would be the input layer. Then there would be a bunch of hidden layers. Then there would be an output layer, 2 output layers. This would be like the pixel of the image, like the dog and the cat. You give it here, and finally you get a dog or a cat. These 2 outputs. And all these nodes would be interconnected. So this needs to be designed some way. There needs to be a way to design this neural net. There are two ways of designing it, which is like the config and the program. The problem with doing with the config file is that you will have to repeat like something like a ResNet, which is like a deep learning model, have like many number of layers which are repeated, these hidden layers. So you'll have to copy paste each of those things in the text file. Inevitably, you might result, you might end up with a config file that is like 25,000 lines of text, which is like really hard to maintain. But if you go to the programming language, you could use like different functionalities there, like while loop and for loop, to repeat these layers and different variables there by which you can reduce the number of lines of code. So most of the people are shifting away from Caffe to something like a TensorFlow, Theano, or PyTorch. Most of these are supported in Python programming language. They also have a C++ API, but it's not really that required. You can achieve most of it with a high-level programming language like Python. It becomes a lot more easier to code it, to maintain it. Torch also supports a programming language called Lua, which is primarily used in gaming. So, so you have like easy interfaces like Python, which is like a dynamic programming language. You can code on top of TensorFlow. TensorFlow itself is written in C++, but they expose these Python APIs which you can use. So those are like the primary difference. So most of them are like shifting away from Caffe to kind of the TensorFlow or Theano at this point. Now, at the very basic level, let's look at what TensorFlow is. TensorFlow can be like at the basic level, what we're doing is operating with tensors. Tensors can be a scalar, it can be a vector, it can be a matrix. In fact, most of the TensorFlow code can be written using a numerical applications in NumPy, using numeric libraries in Python. NumPy is a library. What I've done here is that I've written a code in TensorFlow and I've converted those same code to NumPy. I can do that. Like I've defined a matrix, 2 by 2 matrix with zeros. I've defined a 2 by 2 matrix with ones. I've taken the sum. I get the shape. I reshape it. I multiply it and add it. I take the dot product, and finally I print the results. I can do all this in both using a library that already exists in Python. Then you might ask me, why do I need TensorFlow? I'm already done all these things. All I need is to convert some kind of an input to a tensor format, and I can use NumPy libraries. Not that's not really that straightforward because TensorFlow also provides like GPU supports, distributed system supports. It also helps you different session variables and stuff like that by which you can make deep learning a lot more easier rather than going through directly through function derivatives and all that. Yes, you can boil everything down to ones and zeros, but if you have a little bit more simpler layers on top of it, it becomes a lot easier. So that's where TensorFlow is useful. It boils down to tensors, but there are a lot of stuff on TensorFlow that makes it specifically useful for GPU for deep learning processing. So at the basic level, let's look at what it is a tensor. If you have any questions at all on what I've talked about uh, till now, just post it in the live chat section, and I'll be monitoring that on a side monitor right here, and I'll try to address those questions as quickly as we can. Okay, so just taking a break to let you guys know that a few more people have joined us. So yeah, any questions at all? Just post it there. I'll just address it as soon as possible. So then the question becomes, what is a tensor? What the TensorFlow, what this tensor boils down to. So let's look at, let's take um, uh, a board. I need to draw this. So draw a line. All right. So if you have taken high school physics, you know what a vector is, right? So this is, let's say this is a Cartesian coordinate y-axis and x-axis. So vector is pretty much something with a magnitude and a direction. So let's say this is 5 and it's directed this way, right? So this is a vector. I can convert this to the projection on the x-axis will be, let's say it's 4, and the projection on y-axis, let's say it's 3. I can represent this vector as 4, 3 like this, or 4, 3. I think we have a question. I'll just address that right after this slide. Something about pandas. Um, I'll just address that right after the slide. Uh, um, so this is like one of the way of representing these tensors. Uh, this variable can be represented as 4, 3 this way, and this can be used in TensorFlow operations, like for different operations in TensorFlow. Now let's look at a practical use case. Let's look at something like a chatbot. So let's say chatbot, what would be the input? Input would be a list of questions followed by a list of answers. So let's say that you have a list of questions like, how are you? And the reply to that would be, I'm fine. And right after that, let's say that you have another question like, who are you? Who are you? Okay, there's a space there, sorry. And it responds, I'm computer. All right, let's say that you need to train a chatbot. And you have a list of questions followed by a list of answers, a list of questions followed by a list of answers, and so on. So how can you train it? How can you convert these list of questions to a tensor that uh, just to follow up on that question that person asked, what about? I'm not aware of that. I apologize for that. I can, if you can leave your email or something, I can just find it and respond to you with the answer. Okay, let's get back to this problem statement. So how are you? I'm fine. Like, I'll give the email at the end of the presentation. So if you have any questions, follow-up questions, you can email me as well, just to let you guys know. So how can you, so coming back to the presentation, how can you convert this problem statement into tensor and train a deep learning model to, train these kind of things? So the best way to do this would be to create a dictionary. So you have a dictionary here followed by A would be 0, ace would be like 1, so on and so forth. B, then B would be like, this would be like 21, 22, so on and so forth. So all the words that are present in this question list will be in a dictionary. So what you do is like you map each of these questions to these numbers. So how would be, let's say it's, I'm gonna, like pull some random numbers, 25, 15, 5,000. And the response to that would be something like 56, 21, something like that. So you have a tensor, 25, 15, 5,000. And the response to that would be 56 and 21, right? So how can you so all the questions will be converted to this tensor format. Now the question would be, how can you train a neural net to recognize it? So you would design a neural net with a list of inputs, hidden layers, and finally an output. Each of this would represent something like a line, a function, which is would be w is equal to x plus b. And you would give each of these inputs, each of this as input, 15 and 5,000 as input. The rest would be 0. And depending upon this input, the output should be 56 and 21. So to get these outputs, all the weights and biases in this hidden layer, all these are interconnected, will be modified and changed in such a way that you get these inputs. Later on, when you give the second output, it would again be modified, like that. And finally, you get some kind of a personality for this neural nets. Let's say that I'm using spam from Twitter And when I ask how are you, it responds back, get the hell out of here or something. Then the pattern would be in that way. When I ask a question, it would give me back a spam or an insulting reply. So that's what happened to Microsoft released one of its AI, and a bunch of folks on the internet trained it to act like, to give back derogatory answers. So that's what happened. The training, if the training sample is in a certain personality, the neurons would get trained to respond in such a way. So it all depends upon the training set, how what data you collect. The neuron recognizes those patterns and it would respond accordingly. Let's look at another example. Let's take an example of a picture recognition. So picture can be boiled down to something like pixels, a 28 by 28 pixel. Each of this thing has different pixels, and let's say that I have some kind of an image here of a cat or something, right? And 28 by 28, this matrix can be broken down to a one-dimensional array of 784, 28 multiplied by 28. I think it's 784. Yeah, it is 784. So there would be 784 inputs. There will be a lot of hidden layers. And there'd be two outputs. All this will be interconnected. And this will be either a dog or a cat. Right, so depending upon, so in this thing, all these pixels would be 0. And this thing will be a 1, this thing will be a 1, 1, 1, so on and so forth. If the pixel is covered, it would be a 1. If it's not covered, it would be a 0. And once you feed in that input, 0, 0, 0, 1, 1, something like that, let's say this is a cat, this neuron needs to fire. For a different set of pixels, the first neuron needs to fire. Same way if you do it over and over again, the neural net would be able to recognize this pattern of a dog and a cat, and it learns. So that's how you kind of convert this. I mean, it's a little bit more complicated than this. Next week I'll be covering more details into convolutional neural nets, which is primarily used for image recognition. So once you get more into details of that, we'll be tackling a lot more of these problems, like very complex problems, like you can actually recognize whether a skin condition is a cancer, or you can actually precisely tell what kind of a it can also be used in dermatology. You can look at a star and tell you which constellation it is. You can look at it's also used in self-driving cars. You can look at a street and say whether it's a pedestrian, so on and so forth. We'll get into the details of convolutional neural nets in the coming session. This would be an introductory course. So at the basic level, this is how it works. It's roughly inspired by a biological neuron, not completely. So all these neurons are like, you can put it as each of this is W is equal to X plus B, a line. And each of these lines forms in such a way that uh, finally you get a pattern of the image that is given. To get a little bit more idea, TensorFlow has something called the TensorFlow Playground. You can go here. Let's say that you want to recognize this image. You can give additional number of neurons, increase the hidden layer, increase it here, here, something. And I've given a learning rate of, let's say, 0.1. And I can start in some time. Maybe I need to give a higher learning rate. Let's say 0.3, stop, start. As you can see, yeah, finally the function, previously the point were all scattered, and finally the function was able to recognize the image. So this is one way of, like, uh, pictorially trying to figure out what the function is, so on and so forth. So yeah, this is TensorFlow Playground. There are a few questions online. Does the second line of the dot, is it weight? Second line of the dot. What do you mean by second line of the dot? Um, I don't quite understand the question. Which second line of the dot? Can you elaborate on that? If you can elaborate on that question a little bit more, I'll be able to answer that. All right. Yeah. This was asked by Malikarjun. So if you can elaborate in the previous slide. In the previous slide, yeah, the second, which one? The manual explanation. Oh, I'm sorry, the manual explanation. Yeah, the oh yes, correct. So the second, so yes, it is a dot product. You take a dot product of different matrices with the weight. So it would be, we'll be going into MNIST, which is like recognizing numbers pretty much soon in the coming slides. So everything boils down to tensors. Tensors are actually matrices. So when you do a multiplication, it's actually matrix multiplication. So it's all matrix multiplication, addition, so on and so forth at the very basic level. You don't have to worry about any of that because at the high level, TensorFlow APIs takes care of all of that for you. We'll be going through a small code in the coming slides. Um, so once we go through that, you'll get a clear understanding of what is going on. So yeah, so we've covered what a tensor is. Now let's look at the architecture for TensorFlow. So TensorFlow, I think there's a lag between what I'm saying and what is shown on the screen. So once I read the question and once I respond, there'll be a little bit more, I think like uh, 2 minutes or something delay, just to let you guys know. So you may not get an instant reply as you type in the questions. I'm like seeing myself on a side screen and it's like slightly delayed, just letting you guys know. So let's look at the architecture for TensorFlow. So what at the very basic level, you need to like run these operations on tops of CPUs and GPUs and so on and so forth. So at the top of that, it's a library written on top of TensorFlow, TensorFlow distributed. There are C++ APIs that are exposed to the users. You don't have to worry about any of that. The most of the operations can be done by the Python front end. Then what is getting really popular is the Keras. Keras is like a sort of a layer on top of, it actually lies on top of Python, and also it also supports Theano, and I think it also started supporting CNTK. So what it does is that it's a layer that is predominantly made for deep learning. So TensorFlow can be used for doing any operations in tensors. What Keras have done, that Keras have simplified this to for deep learning alone. So if you're not used to that platform, I do recommend that you guys go and check it out. It's like a very useful tool if you're like coding in deep learning. If you want to get into deep learning and you don't want to, I mean, you're not really that crazy about coding, you can pretty much shave off lots of lines of code if you are doing it in Keras alone. It's much more of a simplified version of TensorFlow with just the basic functionalities that is required for deep learning exposed. Now we'll get into a sample, a small sample. So this is pretty much like an MNS, like it will recognize a number between 0 to 9 as I write it down. So it's like handwriting recognition for numbers. So what it pretty much boils down to is, let me just um, expand the screen. Oh, I must get there, I'm sorry. This is what happens when you take off full screen. All right, so you load the numbers. First line does that, and after that you need to set different hyperparameters. In this, there's something called the learning rate. So if the learning rate is really high, the problem that happens is that you might get skipped. The optimal point might get skipped. You might not, so few of the optimal point along the way get skipped, but you would reach the finish line a lot faster. But if the training rate is low, you will cover the optimal rate, but you will need a lot of GPU processing power to get there. So it's like a trade-off that you'll have to make. And finally, here you can define y is equal to x plus b in terms of x and y. So here you give the image as a 28 by 28 matrix, and that gets boiled down to a 784 array. You can give that as input. Y would be the output, which is from 0 to 9. So what it pretty much boils down to is something like this. It would be a 28 by 28. And let's say that I have a number 1 here. It would be 0, 0, 0, 1, 0, 0, like that. That would be the input to this. And the output would be something, it would be 10 tensors as output. So if in 1, so this will be 0, this will fire, this neuron will fire, and it would have 784 inputs, a lot of hidden layers. And all these things will be interconnected. All these things will be interconnected. And once you set up all of that, you can actually train it with different images of 0 to 9, handwritten images, and it will recognize the pattern for recognizing numbers from 0 to 9. Another way of looking at this is like pictorially representing is that uh, this one line can be represented as ax plus b, y is equal to x plus b. So if I take a Cartesian coordinate, let's say that I have a line called, this is, let's say 2x plus 1, y. So when x is equal to 0, y would be equal to 1. And let's say that I have something here, an entity here that I want to recognize. So all these lines will take a value in such a way that it covers this entity and it gives that form. That's one way of, like in your head, like trying to figure out what this code is doing at the very basic level. I hope that is clear. Let's all right, so right now we're going to jump into TensorFlow Serving, which is pretty much similar to uh, serving is pretty much how you what you do after you trained your model. How can you give it to your customers? How can you share it with the world? How can you, like, okay, you've trained a model to recognize uh, a product, right? And you're making a online retail uh, app or something where you take a picture of an image, you can buy that stuff or whatever. How can you effectively serve it using an HTTP call? Or if you're like doing some kind of a dermatology, a person can take a picture of his skin disease and you will recognize what kind of skin disease it is precisely, almost like a doctor app or something like that. So how can you effectively do that? How can you how can you show this model as a highly available uh, system with low latency and low downtime? How can you dynamically do version control, so on and so forth? So this already exists in traditional programming language. So source control, version control, all this exists in traditional software engineering. But in our existing engineering, like in deep learning, this is very much lacking. All the DevOps that exist in traditional software engineering is somehow lacking in deep learning, and that's what we're working on. We're working on bringing the traditional uh, uh, use cases or traditional source control and version controls and deployment and all that existed in previous software engineering, we're bringing all that into deeper learning. So we're pretty much the DevOps for deep learning. So deep learning in 2005, it did not have source control at all. Right now it has source control. There are great tools in 2017. There's continuous build right now, which happened in 2010. But we have a long way to go. I think 2018 the DevOps will catch up, and by 2020 we will reach a place where you can actually give a data to a deep learning system and it will just return an API. Hopefully we get there. That would be pretty cool to have. So now we ask ourselves, what is TensorFlow serving? How can you, well, I mean, what is the definition of it? Serving is how you apply machine learning after you trained it. At one basic sentence, that's how it is. After you trained it, what you do with it is serving. So previously, like a couple of years back, deep learning was primarily focused on research. So in research, you don't really need to, say anything about serving because once you trained it, that's it. I mean, you can put your deep learning inside a Flask or something, and you can like simply show it to the world, so on and so forth, and people just call it a day. So not a lot of effort went into serving it, but a lot of effort went into training and extracting of data, so on and so forth. But we are primarily focused on TensorFlow serving, which is like an open source library. We can load multiple models in one single process. So you don't need to like load each model at runtime. We can load many number of models in one single process and serve each of them to multiple clients. It's low latency and it's online. The online is a little bit misleading because you can actually make it offline. You can do an app on your Android itself without connecting to the network, and you can do inference or predictions without any connections to a network at all. So, and you can load multiple versions of the model. So let's say that you have one version serving the clients and you want to put in another version. You can actually do that without any downtime at all. All the existing requests from the clients for the existing version will be served. The new version will be loaded. Only then the old version will be taken offline. So there would be absolutely no downtime. Pictorially, this is what it boils down to. It is a C++ open source library. I will tell you how you can install it and so on, and how you can use it. And if you're trained your model, you can uh, send us the weight file or the checkpoint file, and we can serve it for you. So this is pretty much how TensorFlow serving works. There's a data scientist trains the data with TensorFlow, and finally you have the model. And what happens here is the question. So that can be an HTTP call, a remote procedure call, or it can be in the client itself offline that can be used to serve the client. So the architecture of TensorFlow serving boils down to something like this. There's a lot to take in. I'll try to simplify it. So what happens is that once you train a model, you get something called a weight file. A weight file is a file. It's like a huge file, right? So if you are serving that weight file to clients at runtime, and if you are querying the disk each time the client makes a call, you need to do a disk upload each time. So that would be inefficient. So TensorFlow serving provides a way by which you can actually upload everything during runtime to the memory, and each of the client requests is served dynamically at runtime. So there'll be no latency in terms of disk read and so on and so forth. Loader takes care of that. Different client requests are handled by the server handler, and the dynamic manager sends the request to the right model just in case you have different models running in parallel. Like I said, I'm just going to remind you one more time. If it's like getting too complicated, just leave a question there. I'll just try to respond as quickly as possible. Yep. So what are the different APIs? So we have like pretty much any machine learning. We have a predict API, we have classify, we have regress. Then finally, we have something interesting called the multiple inference API, which is pretty much you can combine many of the previous APIs like predict, classify, and regress in one single RPC call. So that's like super useful. So all this can be combined in one single RPC call, and you can send it as one request. All that would be done, and the results will be returned to you. Now, now let's look at a few. Let's go back to this example. So once you train this model, right, you will get a weight file or a checkpoint file. The checkpoint file needs to be converted to something called the saved models. Saved model is a mapping between the output to a human readable format, and it's a serializable format. So if I go back to here, the weight file needs to be converted. The actual output, let's say there's a dog and a cat classifier. This when this thing fires, it's a dog or a cat or something. It's actually one level before that. When this thing fires, a dog or a cat. All this needs to be mapped to a human readable dog, cat, or a number from 0 to 9, or a chatbot dictionary, and so on and so forth. All these needs to be mapped. That is done by the saved model. Saved model is a universal serializable format for TensorFlow models. It's available for TensorFlow 1.0 and upward. Metagraphs are metadata that you can leave in the graph during train time. So during training, there are lots of metadata that you can leave for optimizing training, like something like dropout layer and so on and so forth. All these are not useful during serving time, so you can take that away. So uh, the saved model helps in that. Once you save the model, you can give the dropout layer and so on and so forth. And finally, you can give the signature definition. Signature definition is kind of a mapping between all these numerals to a human readable format. So that would be it for the slides per se. Now I'll go through a small exercise of actually installing a few demonstration, a practical demonstration on installing TensorFlow model in an AWS machine. And I'll also take you through a demo of what our company has built, a few of the APIs that we have built, and so on. Any questions? Just post it there. Yeah, well, just let me know that. Any questions at all, just post it in the comment section. So we're a company called Simple Intelligence. So what we do is like we provide an efficient way by which you can serve deep learning models in a production-like scenario. So what you need to give us is like you need to train your models if you need to add your API. Let's say what you need to give us is a name of your model. You need to give a description of the model. Then this would be just a display image. Then this would be the saved file, like I already mentioned in the previous slide. Uh, this saved model file, you need to provide us that, and a Python client and a data file. Once you sign in, there are instructions on how you can write this Python data. And data files is pretty much like a dictionary or something for, it could be a text file for converting these numbers into human readable format, something like that. Uh, Once you provide us all these things, we can actually provide, we'll just provide an API for you. If it's a general API, if other people uses it, whatever money we make, you get to keep 80% of it. We keep 20% for maintaining the platform because we need to pay AWS, so on and so forth. So this is one of our API. You can describe an image. Let's say I use some image that I have. Let's say that I'm using this image. It's Donald Trump's image. Let's say I use that and I test it. A man in a suit and a tie is standing next to a woman. I don't think there's a woman there, but the second result is true. A man in a suit and a tie standing in front of a building. A man in a suit and a tie. When you're using the API, you would also get the probability by which each of these answers are true. I think the first one would have a lower probability. Um, it's not returned in any order. We can try one more image. Like what is this? Elephant? Yeah, something like that. So that's a picture of me with my dog, and I test that. A man riding a bike with a dog on a leash, a man with a bike with a dog on top of it. Yeah, so a few of them would have low probabilities, a few of them will have high probability, so on and so forth. So just sign up if you want to write models for us or if you want to use our APIs. Just sign up on simpleintelligence.com. We're in private beta right now. We're only taking a few users because we don't have. We're like a new startup taking private beta users. So yeah, we might be not be able to approve everyone who signs up, but definitely if you want to write a model for us, just let us know. We'll just approve it right away, and you can host your models here. And if anyone uses your models, you will be getting a cut of the money that we make, and we keep a small cut for maintaining the platform. Any questions? If there's any questions at all, just post it there. There's a slight latency between what I'm saying and when you guys are hearing it, but don't worry, just post it whenever you can. I'll just address it as soon as I see it. Okay, right now I'll spend a little bit more time. I think I have like around 15 minutes more. I'll spend a little bit more time into how you can get this all up and running on a machine. So what I pretty much do is I use AWS machines for specifically my use case. So what I have here is like an AWS. This is pretty much what I hope most of you have. So yeah, there are a few questions online. I'll just address that quickly. Is there any sample of existing models? Yes, yes, there are samples for the existing models. I will tell I will actually it's in when I'm going through how to install the TensorFlow serving on the AWS machine, I will go through how you can do that. And once you sign up, you will also get an instruction on how you can upload your models. And that instruction has the link to a GitHub page, and that GitHub has a lot of samples on how you can do how you can upload your models. And if you have any questions at all, I'm going to just leave my email here. You can mail me. Yeah, I've just left my email there. You can mail me any questions at all. Uh, I usually respond pretty fast. So let me take you through how you can install our code and how you can like develop application in AWS. So pretty much this is what I mean. I think most of you have used AWS. So this is what an AWS, UI looks like. You start with the instance. You need to launch an instance. So what I usually do is that you have a bunch of options. I usually go to the community and I search for uh, the TensorFlow or something like TensorFlow Ubuntu. So the good thing about community is that you already get machines with like TensorFlow installed in it. So you don't have to like get a fresh machine and start with the installation from the scratch. That would be like really, really difficult. You can actually get a machine with like TensorFlow and everything installed in it, and you can take it from there. I'll show you the installation step anyway. You have a bunch of options. There are like cheap options like micro and medium. Then there are like really expensive options like G and F, all that. GPU. Don't go for all of that. These memory optimized stuff. Yeah, that's gonna cost you a lot of money. So what we can do is like make some kind of a proper trade-off. Not too like not really high quality so that it won't burn a hole in your pocket, but not really low quality so that you can actually run pretty much most of these trainings and serving and all that. So C4.2x machine should do. You can actually do it in your local box if your laptop, I mean, if your desktop is good enough. If you're a good gamer, you might have a good GPU, but I'm not a gamer. So anyway, so I use the C4.2x machines for my training and serving. I can increase the storage to pretty much, let's say 100, and I can review and launch it. I launch that. I choose an existing key. Uh, I have already an existing key. You can actually create your key from scratch. Then I launch the instance. So that instance is getting started up. Once it's getting started up, I can remote to that. Let me just refresh the page. Yeah, now it's running. I can click that. I can connect. I can do an SSH from my machine. Why is it taking so long? Maybe it's still initializing, so it's going to take a little longer than we thought. Yes, finally we are connected. Now there are a few instructions on installing TensorFlow Serving, so let me go through that. So this instruction is available when you sign up to our website. You can go through these instructions on how to install TensorFlow Serving on your local machine or on Amazon EC2 machines, depending upon what you want. So I mean, a CPU should be fine if you want to serve your models. If you want to do training and stuff like that, you might need a GPU. So let me take you through a basic example of how to install it and serve a simple model. So I'm going to create a directory. Most of my code is going to be in here, and I'm going to go inside that. Then I need to download something called a Bazel. Bazel is pretty much kind of a container that Google has provided. So it compiles everything and puts everything in a container for you that you can run, because there would be symbolic links to all the libraries that you want, so on and so forth. That's needed for compilation. So we'll just get that. Once that is downloaded, you might have to install that. And yeah, I have to change permissions, install it, and then change the environment variable. If you're going through this exercise with me, that's also fine. You can, like, if you run into some kind of an issue, you can just ping me straight away. I'm watching my chat section, so I'll be able to reply. Then there's something called the gRPC format, which is used for remote procedure calls by Google. You also need that because the TensorFlow serving would be loading these things into memory. And once it is loaded to memory, you might need to make calls uh, through an RPC format to a remote procedure call. And once it processes it, it will return back the results. So you install that. And then there are like a bunch of additional libraries that you need to install. Oh, it's taking a while. Once that installation is going on, you can actually post any questions you have. I'll try to reply it. And finally, I'm installing the additional libraries. I don't need a lot of brain power for uh, you know pushing enter on all these commands. Unless I run into some kind of error like this, then I need to answer a few of your questions if you have any. Let me just remove this uh, sudo. There. Oh, you need to do that. So once that is configured, we will try installing the additional libraries. And once that is installed, I'll take you through a small example on how you can serve a model in a production-like scenario. So while that installation is going on, you can search for TensorFlow Serving. TensorFlow Serving. So this page would give you pretty much all the information that is there needed for TensorFlow serving. Our engine is built on top of this open source framework. So once you have a good knowledge on this, onboarding your models should be like really easy. So this is TensorFlow serving, like the open source page. We have slightly a modified version for our use case. So this will give you a good idea if you want to do an independent project on TensorFlow serving and to serve that in production, so on and so forth. My thing is getting installed. That's done. Let's install that. Let's that get installed. Oh boy. You know what? I knew this was going to happen. So let's just go to the next steps. I actually have the system, most of the things installed anyway. But if you come across any compilation errors, just shoot me an email. This should be like resolved in the you can actually do Google search of this error message. This is actually an installation for an open source library, which should be widely supported in the open source community. I have gone through this exercise anyway, so all those libraries are already installed for me. So I can just go through the next step of getting the code, which is actually more important. Let me take you through the code of actually how you can serve deep learning models in a production-like scenario. So next step would be to clone this is where our code lies, simple intel serving. That's where most of our there's another question. Is laptop with 256 GB fine for small application? So your disk space does not matter that much. So a disk for when you say, yeah, for learning purpose, yeah, it should be fine. What matters is your RAM. So it needs to have a high, because most of these models would be loaded to memory. So disk space 256 is plenty. 256 gigs is plenty. But the problem is your RAM space. If you have, yeah, if you have like a decent RAM space, you should be able to run it. Disk space is like kind of irrelevant because most likely while you're learning, you'll be going through models that are in the ranges of MBs rather than GBs. So uh, don't worry about the disk space. What you should be more concerned about is like your RAM space. So let's get the serving part. So I got the code for that. So once I go into that code, let me take you through a few of the things that you need to uh, give us for hosting your model. So this is our version of the code, of our TensorFlow code. 8 GB RAM, you might struggle a bit with for learning it should be fine. So I'm reading the comment section on a few of the questions. So like Malikarjun asked whether 256 GB with an 8 GB of RAM, whether that should be fine. Yeah, you should be fine for like simple models, but for like really complex image training and stuff like that, you might find it really difficult. With that configuration, you might have to get along with SSD. I get it. You might have to get a GPU per se from. So if it's a high-end model, you might have to get a GPU from Amazon. But if you are like learning and if you're trying to do that 0, 1 to 10, that I mean 0 to 9 recognition, the handwriting recognition, to learn that, this should be fine. And for installing all this, what I'm showing right now, the configuration that you were provided is just fine. You can do all this configuration in the machine, all this installation in the machine configuration that you have provided. All right, so this is the version of the TensorFlow that we have. So if you go to the examples, there is something called the inception client, and there is something called the inception saved model. So this will take you through how you can convert a checkpoint file to a saved model file. So a checkpoint file is a file that you get after you train the model. And once you train it, you will get a saved model file. And you will upload that to us if you want to host it. And even if you're hosting it on your own for an application that you're writing, let's say that you're an app developer and you're writing an app for yourself, you will need to convert that checkpoint file to a save.pb file. Then there is a client file. The client is pretty much calling the different APIs of TensorFlow Serving. There's a predict request. So you will give an image, and the image will be converted to, would be passed to the predict request, and the predict would tell you what kind of image it is. So the only difference between the open source TensorFlow and ours is that if you want to host it in our platform, you'll have to give the client file in a certain format with process and init. So init, you can pass in the data files and everything. That can be a dictionary, so on and so forth. And process will be the list of inputs that the clients of your model will provide. So that can be a base64 of an image. It can be uh, a list of question and answers for a chatbot, so on and so forth. You can give that, and with that, we'll predict. You can predict. Uh, you can make a prediction for the image or for the text. So you can make a, like, this is an image of a cat, or this is an image of a dog, so on and so forth. So I have a few things installed here. So I have the save.pb file loaded in save in. Let me hide this. So here I have the save.pb file loaded. It's under one. So yeah, I have a saved model, saved underscore model.pb file. So this is TensorFlow Serving. I'm going to run TensorFlow Serving in port 9000. The name of the model is Inception, and this is the path of the save.pb file, which is like the checkpoint file. I run that. Everything is loaded to memory. Right now, I'm going to test this thing with like a picture of an elephant. So I'm going to use, let's say, downloads. Uh, I've had a few. Let me say download. This is the picture of an elephant I've copied to that machine already. So I've already loaded that to memory, and I'm gonna use a client. So that is the Inception client that I showed you. Right now, it's going to go through this server, and I can give the image that I want to recognize. I'll click enter, and it will recognize it for me. It's an African elephant, it's some Indian elephant, and there are like a bunch of other uh, like predictions, but those have like low probability. So the first one is Tusker, an African elephant, and Indian elephant. Those have high probability. The warthog and the chain that have like really low probability. So yeah, so I think we're 7 to 8 was our time. We're just done with most of the trainings this week, the session this week. So next week I'll get into a little bit more detail into convolutional neural nets, recursive neural nets. I'll update on the meetup what the next session will be. I'll go into a little bit more on the detail of how you can exactly upload the models, how you can write it down, a little bit more detail into the coding of clients and saved models, how you can do that in TensorFlow Serving. But today we didn't have time for that because we needed to cover the basics and everything. But next week we'll be covering most of that as well. So yeah, that's pretty much it. I think I've left my email here, which is rahults@simpleintelligence.com. Oh, thank you. Yeah, somebody said it was a good session. Thank you. I appreciate that. Yeah, so for any questions or comments or anything at all, if you want additional resources, you can sign up on our website at www.simpleintelligence.com. I'm going to type that here. Simpleintelligence.com. You can sign up there. Uh, yeah, I mean, if you guys are like, you can go up there, sign up. We're taking beta users, so once you sign up, I'll approve it. If any of you have any questions, I'll answer that right now. Apart from that, we'll conclude on the session for this week. I think Rahul had a question, some intuition on the variables to use. I don't. Uh, I don't quite get the question. Thank you for letting me know. It's a good talk. I don't. I'm not quite sure I follow your questions on the variables to use. What do you mean by that? Yeah. If you can elaborate on that question, I can address it. If if not, you can like always reach out to me in my email. I respond pretty quickly. I think Rahul Kumar, yeah, I think you had a question over my email. You got my email from the meetup. I responded to that with a few clarification. If you can respond back, we can try to resolve your problem. So yeah, that would be all. Oh, input and output variables. So, yeah, I saw your email. I'll respond to that quickly right now. Um, I've asked a few clarification questions in the email, and if you can address that, we can resolve it. So that will be all for this session. So I'll plan a next session next week. Uh, yeah, and I'll also put out the agenda for next week, and we can take it from there. Thank you, guys.